Hello everyone, my name is Jessica Florencia, and today I'm going to present my paper titled Developing e-learning for Educational Robotic Arm Training. As an introduction of the paper, knowledge management is an important topic nowadays since knowledge is considered as a valuable asset for company sustainability. The purpose of managing knowledge is to capture and store the standardized knowledge in a knowledge management system so it will support knowledge sharing happens better. There is a case where there is a company that concerned with knowledge sustainability wants to help a training about robotics using an educational robotic arm. The training method that is used is flipped classroom as scaffolding, which are branded learning and collaborative learning method. In order to support the training happens effectively and efficiently, a knowledge management system in form of e-learning should be developed. The research objective of this paper is to develop an e-learning that contains adjustable and interactive content related to industrial robots and the robotic arm. The e-learning developed is used to support knowledge sharing effectively and efficiently. The method used to develop the e-learning was a model and prototyping-based method. So, as can be seen in the figure 2, the process starts with analysis phase, which consists of problem identification, object and project scope definition, literature review, and data gathering. Then the process continues to the design phase that consists of data analysis and curriculum development. In the development phase, the process done is content development, learning management selection, and a set of prototyping cycle, which the process of configuration, demonstration, and testing of learning management configuration is done iteratively until the e-learning is accepted. After the e-learning is accepted, the implementation phase is done by launching and implementing the e-learning. Then lastly, the evaluation is done by reporting the results and discussion, as well as give the conclusion and recommendation for the further study. Then now, for the curriculum development results, there are 4 topics that is being defined, which are preparation course, beginner class, intermediate class, and advanced class. For the preparation course, there are 3 topics covered, which are industrial robots, introduction to robotic arm, and controlling software. For the beginner class, there are 3 topics that is being defined, which are configuration and installation, teaching and playback, and write and draw. For the intermediate class, the topics that will be covered is blockly programming, and in advanced class, the topic covered is Python programming. Then the syllabus for each courses is being developed. Table 2 shows the syllabus of intermediate course. For each courses, the syllabus consists of basic competency, learning objective, learning topics, learning activity, assessment, and learning source. Then after the syllabus is being developed, the content is being developed based on the syllabus. There are 2 types of content that is developed, which are learning sources and assessment. First, for the learning source, there are 3 types of learning source developed, which are digital module, video presentation, and video for practical training. And for the assessment, there are 2 types of assessment, which are quiz and video or report submission. Then the learning management is being configured and tested. This is initiated by choosing Moodle as learning management system. Then the process happens in 4 cycles. The table shows the summary of the prototyping cycle. So in the first cycle, the configuration is done by doing initial appearance and technical settings. Then the demonstration is done by e-learning presentation, and the evaluation is done by doing survey and direct feedback. Then the evaluation results state that the e-learning needs improvement in appearance and needs to be added more activity and features. In the second cycle, the configuration is done by modifying appearance, exploring user roles, and configuring courses. The demonstration and evaluation is done through focus group discussion. And the results of evaluation stated that the e-learning needs improvement in features and technical aspects. In the third cycle, the configuration is done by modifying technical aspects, including adding user with bulk user registration and adding features. The demonstration and evaluation is done by doing focus group discussion. The evaluation results state that the e-learning needs the course content and material should be refined. Then in the fourth cycle, the configuration is done by fully adding all activity and refine all activity in the e-learning. The demonstration and evaluation is done through trial with user acceptance tests, and the evaluation results that the e-learning is good. Now, for the testing happen in the fourth prototyping cycle, it will be discussed further. The evaluation is done by user acceptance test using survey with 10 participants. There are 23 statements divided in 6 categories measured in 6-point Likert scale. In the table, this is the results of the survey and already categorized in the 6 criteria. From the table, we can see that the highest average score is from the education system quality criteria, which is 5.38. And the lowest score is from perceived usefulness criteria, which is 4.67. But here, the lowest score is still considered as good. And based on this result, all the participants are agreed that the system successfully provides various features and educational media, good system quality, clear and understandable information, as well as responsive system service. The e-learning system also can satisfy student learning needs and useful for the students. As a conclusion, from the evaluation, the user satisfied with the e-learning information, various features, service, and technical quality. This indicates that e-learning is successfully support knowledge sharing to the learners effectively and efficiently. The e-learning can be implemented and used as a standardized learning source and platform to support its robotic training in Indonesia. And recommendation for the further study is to utilize the e-learning developed for training with scaffolding and flipped classroom method combined with video conference media for synchronous discussion or learning for a better learning process. I think that's all from me. Thank you.